Hi everyone, welcome back. In today's video we are going to build the code that will let us manually drive our rover car while collecting training data at the same time. Okay, this is the idea. As we drive using the keyboard, the car will capture images, record steering and speed information, and save everything so we can later train a self-driving model with this information, with this data. So let's get to work. Starting with this car class, inside it we have this steering enum. The steering class is just a clean list of our 4 driving directions: forward, backward, left and right. And yeah, those angles get saved with every image we capture, so later our self-driving model knows exactly which way the car was moving. Yeah, in the car class is the start of the show. This is the brain's connections to the hardware. So when we create a car object, the first thing it does is set up the 4 motors: front left, front right, rear left, rear right. Each motor gets its forward pin, backward pin and enable pin, so we can control direction and speed independently for every wheel. Then it initialized the pie camera too as soon as we started, and we've got a live feed from the camera ready to capture frames on demand. There is also a helper method called capture image, which grabs the current frame from the camera, grabs the top tier of to focus on the road ahead, and resize it to exactly 200 by 66 pixels, size that it's required by the model. That smaller image is easier to process and store, and it's perfect fit for many neural network architectures. Okay, the motion methods, forward, backward, turn left, turn right, all allow the same pattern. Capture the current camera frame, create a lock with timestamp, wheels speed, steering labels and steering angle, and finally send the right commands to the motor so the car moves. So all of them do the same in its particular way. For example, forward runs all wheels in the same direction. Turning left runs the right wheels backward and the left wheels forward, making the car pivot. Well, we also have the stop to cut power to all motors instantly. and shut down to stop everything and release the camera. Yeah. Now it's time to uh, work in the car controller class. So, which is the bridge uh, between the keyboard and the car, really? Well, it starts by keeping a reference to the car object, so it can control both motors and camera. The handle manual step method runs every cycle and listens for keyboard inputs. By default, the car is stopped. Nothing moves unless you press a key. So, when W, um, for example, is pressed, the car drives forward, locks the information. Um, yeah. So S drives backwards, A left, D right. Um, yeah. Every action also sends the capture image and the metadata to our login system. So we are collecting label driving data in real time. And yeah, finally, the control loop bring the controls runs an infinite loop with a short delay to keep things smooth and stops uh, cleanly when we hit the Control C to close everything. Yeah, so okay, the last piece of the puzzle is the network communication module, and this is what actually stores our training data. At the top, it makes sure we have a data folder ready to store everything. Um, yeah, the main function um, handle capture data is called from the controller every time the car moves. Instead of saving the file right away and pausing the program, it starts a background thread yeah, that calls the log car data function, which does two things. First, it saves the capture camera frame as a JPG file, naming it with the timestamp, so we know exactly when it was taken. And second, it opens CSV file and appends a row containing the image file name, the speed of all four wheels, the steering label, and the steering angle. Um, because this is done asynchronously, the car never pauses to wait for the data to be written. We can keep driving smoothly while building um, yeah, the data set in the background. Now it's time to try to execute our code for the first time. In order to do that, we need to activate the virtual environment where our car lives. So, execute the corresponding command. After that, try to execute the code, and you will face this error with the CV2 library. And this is because I forgot to install this library in previous steps. So just follow me. Just install this corresponding library in the virtual environment. Now, if you try to execute the program again, you will face a similar problem. And looks like it's the same problem as before, missing libraries, but this is different. And it's different because these libraries, live camera and pi camera 2, are essential libraries on the Raspberry Pi and are installed by apt, not by Pi. So yeah, a normal virtual environment can see these libraries. To make them visible, we need to use this command. Yeah, so system side packages, and now yeah, the virtual environment can import the apt libraries, can see these libraries. So, and after that we can reboot. Now if we try to execute our code again, we can see that it's working. Here a demo.